Good evening and welcome to this really wonderful presentation tonight as part of IMPACT Melanoma's Melanoma Symposium forums. I'd like to welcome you. My name is Deb Gerard. I'm the Executive Director for IMPACT Melanoma. For those of you who don't know IMPACT, we've been around for about 20 years. We are national thought leaders in the area of early detection, prevention, and education programs. You might know us best from our Sunscreen dispenser program across the country. And please, at the end of this presentation, feel free to take a look at our website at impactmelanoma.org. And there's definitely something for everyone there. So again, welcome. I'm very excited about our presentation tonight. We have two really special guests with us tonight. The way this will work is that both Dr. Fisher and Dr. Lin will do their presentations, and then we'll have an opportunity for question and answer. As you have questions, go ahead and put them in the chat, and somebody will be collecting those, and we will be able to answer as many questions as we can in the time period. So welcome. Thank you for joining us tonight. I'd like to introduce our guest speakers. Dr. David Fisher is the Chief of Mass General Hospital's Department of Dermatology. He also serves as Director of Mass General's Cutaneous Biology Research Center and Director of the Melanoma Center. Dr. Fisher is Professor of Dermatology and of Pediatrics at Harvard Medical School. His research has focused on understanding the molecular and genetic events which underlie the formation of melanoma as well as skin pigmentation. As a clinician, he has worked to translate these understandings into advances in diagnosis, treatment, and prevention of human diseases related to skin and associated disorders. Dr. Fisher is a 2020 inductee into the National Academy of Medicine, and most importantly, he's a member of the Medical Advisory Board for IMPACT Melanoma. So thank you, Dr. Fisher. Dr. Jennifer Lin is currently the Director of Melanoma Risk and Prevention Clinic at Brigham and Women's Department of Dermatology, and also directs the dermatology component of the Dana-Farber Cancer Institute's melanoma program. She's passionate about caring for her patients and developing in research involving early detection and intervention and topical treatments for melanoma. We're also really thrilled to have Dr. Lin with us. She works with us on multiple projects in the course of the year, and thrilled to have her join us tonight for this conversation. So I'd like to start with Dr. Fisher, and he'll share his slides with you.
Okay, thanks very much. It's great to be here. Thanks for the invitation, and I'm delighted to share some ideas around the place of where we are in melanoma, sun safety, some of the aspects of this. Obviously, this is a much bigger topic than what can be discussed in a brief talk like this, but We're very lucky that the melanoma field has been moving very rapidly. There have been some major reasons for optimism and excitement, and I'm delighted to share some of those with you in the roughly the next 20 minutes or so. Let me just figure out how to, okay. I have some financial relationships with companies. I always like to show this. None of these companies are selling products that have anything, well, at all actually, but certainly that have anything to do with the talk that I'll be giving this evening. So I'm going to begin by talking briefly about therapeutics, and then I'll be moving into our understanding about how melanoma forms and issues related to how that occurs and how we might be able to think of prevention. But in terms of therapeutics, this is primarily a topic that has focused on advanced disease. And as probably many of you are aware, there are the two categories of treatments, what we call targeted therapy, that is largely focusing on the BRAF mutated class of melanomas, roughly half of cutaneous melanomas, and immune therapy, immune checkpoint inhibitor therapy, which has had an enormous advance in our use because it has generated really durable and major responses in patients. The two major advances that I'd like to focus on briefly in the next few moments involve two key topics. One is the application of these therapies for earlier stages of disease. That is not only restricting the use to the most advanced stages of metastatic melanoma, but nonetheless using them instead at earlier phases of disease. And then I'll also talk about a new checkpoint, inhibition of a new checkpoint, the anti-LAG3 scenario. So the first of these is this topic called adjuvant therapy. Adjuvant therapy is a treatment which is applied to patients after the primary tumor has been removed, or any circumstance where there is no visible tumor remaining, but in a setting where we know based on statistical experience that there is a likelihood that there is a small population of invisible tumor cells, too small in volume to be detectable by standard radiographic means, by X-rays, CAT scans, MRI, things of that nature. And the goal of this type of therapy is that even though there's nothing visible, even though it is too small to visibly detect, the goal is to eradicate that microscopic residual disease with the goal of benefiting patients through what is in essence a kind of a statistical argument, because you're not measuring shrinkage of an existing tumor, but you're trying to achieve a statistical benefit in a population of patients where clinical trials have demonstrated an advantage, a lower likelihood of relapsing for patients who did receive such a treatment as compared to those who did not. The benefit is to prevent recurrence. The risk of such treatment is that you will be exposing the patients to the risks of toxicity of any drug, including these specific drugs, when in fact, because this was only a statistical risk, some of these patients actually may have been cured and not needed the drug at that phase. And so there may be a risk of toxicity that actually was not necessary. And that risk is balanced with the potential benefit of avoiding a recurrence that otherwise could be very dangerous to patients. That is what adjuvant therapy is. And this has now been established to be of benefit statistically in settings that originally had been exclusively the domain of advanced disease, where we're giving systemic drugs, we're giving BRAF targeted therapy or anti-PD-1 immune checkpoint inhibition at earlier phases of disease. And most recently, this has now all the way gone down to cutaneous disease that's called stage 2 high risk, which is actually restricted to the skin, not necessarily even involving lymph nodes in certain instances like this. But the challenge is to identify which of these patients will benefit, because a higher and higher fraction of these patients probably would never relapse anyway. So is it worth it to expose these patients to the risks of side effects, which can be very serious in a very, very small fraction of those patients? This is an active research area and a question that we feel really needs to be answered. Nonetheless, the availability of these drugs at earlier phases stands to avoid relapse and allow patients to receive the benefit of these effective drugs at earlier phases of disease, which is actually a very significant fraction of patients diagnosed with melanoma these days. The other therapeutic advance in recent times has been the addition of a drug that targets a new checkpoint. Relatlimab is a new antibody targeting a different checkpoint known as anti-LAG3, and has recently been approved on the basis of modestly improving the efficacy when combined with anti-PD-1 therapy. Anti-PD-1 has now been around for a while and offers very successful outcomes for a fraction of our patients, but not enough. And combined with anti-PD-1, anti-LAG3 has improved responses, albeit modestly, but it has done that with minimally increased toxicity. Another combination where it was combined with anti-CTLA-4 or ipilimumab is significantly more toxic. And that challenges the advantage of combining these drugs. Greater benefit from efficacy, but very significantly greater toxicity, and that can be very dangerous. Here, the magnitude of benefit, while modest, is associated with a relatively minimal increase in toxicity, which is wonderful. And now this leads us to the next key questions, which is which patients will benefit? And applying now, rather than just the minimum circumstances where this has been studied so far, trying to test this in multiple clinical scenarios to see exactly what the benefits will be. For example, in relapsed patients, for example, in patients who have had anti-CTLA-4 and questions of that nature. I want to move now to more early stage disease and some of the fundamentals of skin biology that are very important in our understanding of how melanoma forms in the first place. And what this slide is showing you is a cross-section through human skin. And what you can see, the very outer layer here at the top, so the sun would be shining down from above, and you see here these fibers which represent actually the dead layer of our skin, known as the stratum corneum. Deep to that is a layer called the epidermis, this purplish layer over here. And then there is a dermal layer, the dermis, which is deep to the epidermis. And right along the junction where these arrows are pointing, the junction of the epidermis and the dermis, there are rare, relatively uncommon cells, which are stained in the image to the right, so that they stand out as these brown stains. These are the melanocytes. Melanocytes live in a very discrete location at the base of the epidermis, near the junction to the epidermis. And while these cells are not very abundant, they synthesize melanin and they secrete the melanin. And most of the melanin in our skin, most of the pigment, is actually contained not in melanocytes, but in the keratinocytes, the abundant cells of the epidermis. So if you have pigment in your skin, most of it is actually residing in the other cells of the epidermis. The melanocytes are the factories that make that melanin and then export it back out to the other cells in the epidermis. And the crosstalk between the keratinocytes and the melanocytes is extremely important in multiple ways. And I'm not going to go through huge detail in this particular cartoon, but this is an example of how ultraviolet radiation causes melanocytes to make pigment, the tanning response. And the pathway is indirect because UV acts on keratinocytes and the nucleus and the DNA in those cells, injures the DNA, leading those cells to make a hormone that is cut up into little pieces, one short fragment of which, known as melanocyte stimulating hormone, or MSH, activates melanocytes through binding to a receptor on the surface of those melanocytes. And when these melanocytes become activated, the pigment pathway is stimulated, and these little vesicles, these little almost like balloons filled with melanin, get produced and then actually shipped back out to the keratinocytes, as I mentioned a few moments ago. So the pathway begins and ends at the keratinocytes, but with very close communication between the two types of cells. Now, some of the individuals who are at relatively elevated risk of melanoma and other skin cancers are people who have red hair and very light skin pigmentation. And it is now known that genetically, those individuals have variant forms of this receptor, the MC1R gene and the MC1R receptor. And because their version of this does not respond to MSH, to produce cyclic AMP and this pigment response, these individuals don't tan very well. They essentially have a block, a genetic block to the tanning response. And this is the reason for that. Because that non-functioning variant resides right in the middle of this important signaling pathway for pigmentation. But what is important, nonetheless, is the question of whether they might actually have an advantage. And I want to pose this question, whether sun-seeking behavior is intrinsically a bad behavior. And we of course, urge our patients to avoid the sun and to be safe in terms of the sun. But there is research that has suggested that actually there is a reason that humans are inclined to feel good in the sun. And this comes from exactly this very same pathway, because another peptide that is part of this very same hormonal response to UV radiation causes the release of endorphin. An endorphin that is released from the skin could be shown to produce analgesia, which is pain relief. It could also produce dependency and essentially addiction-like behaviors. Endorphin is an opiate, an endogenous opiate in our bodies. And so the fact that there is an opiate response encoded within the very pathway through which we tan suggests that we have evolved to actually receive the behavioral inclination that this endogenous opiate would trigger. We believe that in evolution, the driver, the reason that this response exists, perhaps was to maintain the ability of UV radiation to produce vitamin D. There is one critical chemical step in the synthesis of vitamin D, that sunlight, and I will talk about this in just a moment, that ultraviolet radiation helps to produce, that otherwise we in evolution had no way to generate. Now we strongly discourage the use of ultraviolet radiation to produce vitamin D. We strongly encourage the use of vitamin D supplements, which can almost always maintain vitamin D in a healthy way. UV is not the preferred way to do this because it comes with cancer. It comes with a cancer risk, skin cancer risk. But in evolution, we evolved, we think, to have this response because when vitamin D levels are very low, there is a strong behavioral response to endorphin, whereas when vitamin D levels are higher, vitamin D could be shown to repress, to actually suppress the euphoria that otherwise is induced by ultraviolet radiation. And so this is a glimpse of evolution, and it suggests to us that the inclination to seek sun and UV radiation is not intrinsically bad. It's actually part of our evolution, but it is something we should assiduously try to avoid because it is dangerous, and there are much safer ways to maintain a healthy vitamin D level. Does melanoma only occur on sun-exposed skin? Well, we think of UV radiation as a very important contributor to melanoma risk, and it clearly is, and I'll talk more about that in a moment. But in this study that was published a number of years ago, it was clearly demonstrated that independent of any ultraviolet radiation, in the red-haired genetic background, there is a propensity to form melanoma completely in the absence of ultraviolet radiation. There is a certain chemical phenomenon we call this reactive oxygen, in which the combination of the red pigment, which is called pheomelanin, with an oncogene that is very common in melanoma and very common in benign nevi as well, combine to give, in animal models, melanoma. And the way we knew that the pigment contributed to this is that we could have red-haired mice that actually have no pigment. So they're not actually red-haired, but they are genetically identical to red-haired mice at that MC1R gene. And when these mice lacked all pigment, they were actually protected from the formation of melanoma. The important message from this being that there is a propensity for melanoma formation even in the complete absence of UV radiation, which means that the risk of melanoma in fair-skinned people is not confined to the portions of their skin that are exposed to the sun. But we must be careful, we must be attentive. We should be getting skin checks, for example, and pay attention to skin, even if it has not been associated or exposed to UV radiation. That said, in fact, there is evidence, and I'll show you some in just a moment, that ultraviolet radiation further amplifies, very significantly amplifies that risk. what is the relationship between benign moles or nevi and melanoma? Nevi and moles we use as an interchangeable terminology for the benign pigmented spots that we see in our skin. And for many years, it has been assumed that benign moles function as a precursor. In most cases, they are perfectly benign, and almost very, very, very rarely, maybe 1 in 100,000 or so, very low frequency, do they actually transform into melanoma. And people have studied the genes that are associated with both benign moles as well as invasive melanomas. But what has also become very clear and has actually been well known to dermatologists for many years is that only a minority of melanomas seem to arise pre-existing nevi. The majority do not seem to arise from in nevus, but rather appear to be spontaneous, which means we have to be attentive to brand new pigmented spots that may arise in our skin because they don't necessarily have to arise from pre-existing visible nevi. When we categorize our skin's pigment, this has been, I'm not in the interest of time going to go through this in great detail, but we categorize, and this has been done by Thomas Fitzpatrick 40 years ago or so, from phototypes 1, which are the lightest skin, down to phototype 6, which are the darkest skin. Phototype 1 is in fact people with red hair who tan very poorly but burn very easily, all the way down to people with darkest pigmentation. And we know a number of features of the skin in terms of the types of pigment that they make. But if you look at the nevi, the moles that these individuals have, you see more and more moles as you go to the lighter and lighter skin types. But surprisingly, people with red hair, freckles, light skin, actually have a surprisingly low number of pigmented moles in their skin that are visible to us. And this has been a bit of a puzzle. And I want to share with you a recent result that we think is perhaps of some importance related to this. And what we had was the hypothesis that perhaps individuals with the red hair background do have nevi, but they're invisible to us because the red pigment is not as concentrated as it would be in the hair. And this red pigment called pheomelanin is less visible to us in skin. Therefore, these nevi may not be visible to us as compared to nevi containing the brown eumelanin pigment. And this was something that we could study in mice because we have mice that are genetically black or genetically red, only containing that one gene difference in that MC1R gene. And here you can see a pigmented nevus, a mole in the skin. This is a cross-section through the skin, and you can see this brownish pigment near the base of the skin. And in a red-haired mouse where we activated the same BRAF oncogene, you can actually see that there is a somewhat abnormal proliferation, but the nevus is much more subtle, very difficult. And looking from the surface, you don't see pigment visible to this naked eye. But using a genetic trick that when that oncogene became activated, these cells would become fluorescent. In fact, it was obvious that there were very striking nevi that were present in the red mice as they were in the black mice. But in fact, if we quantified it, if we activated the BRAF gene identically in either the red hair background or the dark haired background, in fact, the number of nevi was dramatically higher in red-haired mice as compared to darkly pigmented mice, suggesting that the red-haired background has an even higher likelihood of having nevi, but these nevi don't have dark pigment and we therefore don't see them. And this may be part of the reason that it is more challenging to diagnose melanoma in that setting. We also have other tricks where we can demonstrate that these lesions all derive from a single original cell, because using a series of different colors of fluorescent markers, we can see that the clusters of cells all share exactly the same color. We also could use a kind of UV illuminating flashlight and look through the skin of these mice because their skin is very, very thin. And you can kind of make out, only because the mice have a fluorescently engineered gene, that we could even see that these lesions, these nevi are present under the skin. Whereas otherwise, if you just look at the naked eye on the left, you don't see any of these things. And there are some drugs that might perhaps introduce pigmentation that would allow them in the future to be more easily visualized. Finally, what about ultraviolet radiation? What is its role, and especially UVA and UVB? So if we consider, and I'm nearly finished, the spectrum of electromagnetic radiation emitted by the sun, we categorize this along the spectrum of different wavelengths, from very long radio waves all the way down to gamma rays and X-rays, which are much shorter. And these all have very distinctive properties in terms of what they do when they collide with things or try to penetrate them. The visible light portion is here in the middle, and the ultraviolet is directly at the smaller side of this. And further, the ultraviolet portion of the spectrum has been broken down into what we call UVA, B, and C within that region. UVB is the portion of the UV spectrum responsible for the contribution to vitamin D synthesis, for sun burning, the redness and inflammatory response. It does contribute to tanning and is highly carcinogenic because it can mutate DNA. UVA, slightly longer wavelengths, is actually very, very common. It is more abundant than UVB. It is less toxic lumen for lumen. On the other hand, it is very, very, very common. It is a weaker tanner, but it does produce tanning. And its role in cancer, while strongly suggested from evidence, has been less obvious than it has been in the case of UVB. And I just want to mention very briefly, when we think of sunscreens, that there are the mineral sunscreens that essentially reflect the wavelengths, and there are the chemical sunscreens that filter the wavelengths as they come in. The UVB portion of the spectrum is effectively described as the SPF, the sun protection factor. The UVA portion, unfortunately, is not really subject to a standard currently for the existing sunscreens. We want broad spectrum in order to have protection in the UVA portion, and the guidelines around this and the ingredients that will be acceptable to the FDA are evolving. But this is a terribly important area, and the reason for this is depicted, I think, in one context right here on this final slide that I have, which is that when we took red-haired mice that had those invisible nevi that I showed you, and we subjected them to UVA, what we saw is the incidence of melanoma was dramatically increased. Virtually every one of these mice developed melanoma. If we did this identical experiment in black-haired mice with dark pigment, UVA had a minimal effect. But in the fair-skinned background, UVA was actually highly dangerous and quite potent in the production of melanoma. If these mice had no red pigment in the red albino background, UVA also could not produce melanoma practically at all, suggesting that there is a real risk of UVA-associated melanoma in the red hair, fair skin background. And for this reason, we think it's terribly important to recognize that these invisible nevi, or perhaps even red pigment-producing melanocytes that are not within nevi, are potential contributors to melanoma risk. This can occur either in non-sun exposed skin or in combination with UVA, and certainly in combination with UVB, for which the high SPF 30 or above is very important. And again, we want to emphasize that sunscreens that are capable of blocking UVA will be very important, but there is, aside from sunscreen, the entire protection behaviors from the sun-safe behaviors, shade, avoidance of the most intense sunny parts of the day. These are all components for being safe and trying to minimize our risk from melanoma. And with that, I'll stop and be delighted to turn this over to Jennifer.
Thank you. I should mention that I was very lucky and I got to work in David's lab for a few years, and so much of what I learned from him has informed my practice. So you'll see some of the same ideas get reflected. So I was tasked to really focus on the sunscreen part of it. Why do we use it? How does it work? What type should I use? How should I use it? Are there any concerns with using sunscreen? And so we have a lot of good clinical evidence that sunscreen works to prevent skin cancer. The best study was done in Australia. They randomized individuals to requiring daily sunscreen to their face and their hands versus ad hoc use of sunscreen. And over a 15-year follow-up, they showed reduction in squamous cell carcinoma, as well as 50% reduction in primary melanoma. So there's no question that the use of sunscreen, especially when used on a daily basis, reduces the number of melanomas formed in the population. Plus, sometimes the bigger incentive for especially our teenagers is the reduction photoaging. And so in the corner, you can see a photo of a woman who has been a truck driver and experienced a lot of sun exposure on the left side of her face. And you can see over time the difference in her skin quality. So David mentioned that UVA penetrates more deeply. This affects the collagen. So there's less collagen, the skin becomes less elastic. There's usually pigmentation changes, both increase and decrease in pigmentation. So I think one of the important messages is when we talk about reducing your sun exposure, we're talking about over your lifetime. Individuals get worried about, oh, I'm going to be at the beach for a few hours. That's important, but I'm also equally worried about the individual who drives 2 hours every day in the middle of the day, who's not using sun protection because they're getting sun exposure cumulatively over time. Okay. So sun prevention strategies. On the right side, there's a cute mnemonic that was made many years ago. So slip on some sun protective clothing, slap on some SPF sunscreen, slap on a hat, seek the shade, and slide on some sunglasses. And so how do we protect against, ironically, something we were supposed to live with, which is the sun? So sunscreen, one of our main messages will be you have to reapply. It's just not enough to wear it once and then assume you're good for the rest of the day. Avoidance of the peak sun, which most people don't realize that it extends from 10 a.m. to 4 p.m. The use of clothing and hats, which doesn't wear off, unlike sunscreen. Seeking shade, and the use of sunglasses to protect against cataracts. So what's the best? Probably a combination of all of this. It's been shown that shade alone is not enough. So in a randomized controlled trial looking at use of SPF 100 sunscreen versus just sitting in the shade, 78% of the individuals who were just sitting in the shade experienced a sunburn compared to 25% of the individuals who are using sunscreen. So I wanted to reiterate that what we're dealing with is ultraviolet radiation. And again, just like David mentioned, UVC actually is the most carcinogenic of the ultraviolet rays, but fortunately is blocked primarily by the ozone layer. And what reaches the Earth and us is UVB and UVA. And again, UVA is much more abundant. And then because of wavelength is directly proportional to penetration to the skin, UVA penetrates more deeply into the areas where we have collagen, for instance. So sunscreens have come a long way. This is an ad about the copper tone girl, you know, in the time when sunbathing with iodine was very popular. So we've come a long way with what we have available. And the two types of sunscreen, again, as David mentioned, block either against UVA or UVB. And in the US, we only get this term of broad spectrum. So that's what you're looking for when you're choosing your sunscreen. Hopefully FDA will move towards what Europe and Asia have. Europe and Asia have a separate measurement for UVA versus UVB. And these are currently the FDA approved sunscreen ingredients. And again, we're going to talk about physical versus chemical blockers. So just like David mentioned, for physical blockers, they are working by reflecting the light. And if you know, if all light reflects back to your eye, it's going to look white. That's just the natural property. So these are very white looking sunscreens. And the truth is when they're working at their maximum benefit, they should look white. Versus chemical sunscreens, they work by absorbing the ultraviolet radiation, and they transform it to a different form of energy, be it light or heat. Importantly, every time they take a hit, the chemical is quenched. So your supposed force field is waning as soon as you step into the sun. And that's, again, why reapplication is so important. So we know that SPF work, and I'll talk a little bit about how it's measured. Here is an example of what can happen to your skin in terms of the DNA damage. So thymine dimers is the most common UVB form of DNA damage. You can stain for this in your skin. Again, this is nicely showing the upper layer of your skin where the keratinocytes are all injured and how you sort of heal over the next few days. And again, you can see that sunscreen is effective. So if you use sunscreen, those cells do not get damaged. So sun protection factor is a calculation on how good the cream is at protecting against sunburn. And it's mostly measuring UVB. And for practical terms, though, it's more useful to think about it as time. So if normally you would burn in 10 minutes, then using an SPF 15 would give you 150 minutes before you burn. If you use an SPF 30, it would be 300 minutes until you burn. And this is assuming that the sunscreen stays on the way it was applied in the first place. And so that's, again, a big issue with sunscreen is how you apply is very important. Does the higher SPF matter? It does. So the higher the SPF, the more it is filtering out the UV radiation that reaches your skin. So you can see here that from 1 to 30, you're reducing the amount of radiation to 3.3%. However, you also may notice that as you move above 30, that incrementally you're not getting that much more protection. So our standard is to say you need a minimum of an SPF 30, especially as a day-to-day use. And remember, if you go up high, you're gaining in time. So if you know you're going to be outdoors doing something active for more than 2 hours, then it will be longer lasting for you to use something about higher SPF. And again, real world example. So there was one randomized controlled trial that looked at skiing in Vail. They split the face to SPF 100 on one side, SPF 50 to the other side. They assessed the sunburn after exposure, and 10 times more individuals were burned on the SPF 50 side compared to the SPF 100 side. Shade, that's another component of sun protection. It's very good, but especially when you're in an area where there's a lot of reflective surfaces, sunscreen is still needed. So they put electrodes that measured UV radiation in the direct sun versus in a shady area. Under a big tree, you eliminate till only having about a little more than 5% UV radiation. Under an umbrella next to the pool, you cut it down to about 17%. So it's good, it's not perfect. We still recommend wearing sunscreen even if you're sitting under an umbrella. Sunscreen application. So in all these SPF studies, they're using 2 milligrams per centimeter squared, which is a thick layer. Most people only put about 0.5 milligrams per centimeter squared. We give some estimates, so a shot glass full for your whole body. For just the face, about a quarter teaspoon to a half teaspoon. And it's also important to remember to apply before exposure. The sunscreen, especially the chemical sunscreens, have to be absorbed before they can work effectively. In terms of water resistance, a lot of bottles now say water resistant versus very water resistance, and they are measuring how much of the sunscreen stays on after for water resistant for 2 20-minute immersion tests. And so essentially what they're saying is you're good for about 40 minutes. Very, very water resistance, they looked at the retention of the SPF after 4 20-minute immersions. So again, the idea would be you get a little bit more time. Potentially you should reapply after 80 minutes. Towel drying does eliminate a lot of the sunscreen, so you need to reapply after towel drying. And for my melanoma patients, I'm very protective of them, so I usually have them, if they go in the water, and they're planning on staying out for longer, I do have them reapply. So this comes to something where how you apply isn't relevant, and that's the beauty of clothing. So universal protection factor is the term used for sun protective clothing. If you're wearing it, you don't need to wear sunscreen underneath it. And so this is a much more reliable form of sun protection. I've had lots of questions on whether a regular cotton t-shirt provides protection. So old studies suggest that a white cotton t-shirt only gives you an SPF of 3. But at the same time, if you ask around, we don't really hear about people burning through shirts in general. I think there's still advantages with using UPF clothing. They're manufactured to be extremely lightweight, so you're more likely to keep it on in hot summer weather. So there's been a lot of sunscreen controversy over the last few years, and we'll go over that quickly in terms of potential toxicity, and also David already mentioned the potential vitamin D deficiency. So there were 2 studies coming out of lab from the FDA looking at maximal sunscreen application and how much of that got into your bloodstream or reached systemic concentrations. So the first study was small. They only used 6 individuals, and they used 4 of the most common chemical sunscreens, and they had them apply it all over their body as if they're about to go to the beach. And they showed in those individuals that within a day, they reached the systemic concentration where we really need to reinvestigate what this means, so above 0.5 nanograms per milliliter. However, because it's such a small study and we just don't know what it means to have some of these chemicals in the blood, they did not say you cannot use these sunscreens. And then the follow-up study, they included 2 other ingredients. They moved up to 12 participants. I think in this case, they were really trying to mimic use of sunscreen. So these individuals applied every 2 hours, and they wanted to see how long the plasma level of sunscreen lasted for. And with repeated applications, the individuals had plasma levels that lasted from 7 to 21 days. But again, it's a very small study, and it's hard to know what this actually means. So of these chemical ingredients, oxybenzone is probably the best documented. So the chemical form of oxybenzone is similar to a hormone, and hormones cross over cell barriers very quickly. And so it's not really a surprise that it gets into your bloodstream so quickly. So oxybenzone has also been shown to be found in urine and breast milk. On the flip side, and oxybenzone was introduced into lots of products in 1978. So one of the points to think about is oxybenzone is in a lot of other cosmetics, not just in sunscreen. So it's been around since 1978 without any documented harm to humans. And then the rat studies suggested that they could affect hormone function in the rats, but these were rats that were fed the oxybenzone. So in order for a human to reach the level that the rats were consuming, you would have to apply sunscreen to your whole body daily for, this is an estimate, 35 to 277 years. So the other big concern has been the environmental effect. There was concern that the particular oxybenzone could affect the very delicate coral reefs, and to the point that several areas, several locations, including Hawaii, has banned the selling of sunscreen that contains oxybenzone. So how do we protect our kids? The Academy of Pediatrics says if you're under 6, you should not use sunscreen. You should be keeping them in the shade. You should be using some lightweight clothing. And if you're above 6 months, you can start to introduce sunscreen, and you probably want to choose a sunscreen that doesn't contain oxybenzone. A lot of sunscreens now for the feel of the sunscreen use nanoparticles, and there was concern that nanoparticles get into your bloodstream as well. That hasn't been shown to be true. When they enter the skin, they aggregate and they don't go into bloodstream. So the vitamin D question that David brought up also is yes, that the exact rays that make vitamin D are the rays we are trying to block UVB. So unfortunately, sunscreen does block your production of vitamin D. However, just like David said, if someone is consuming a healthy diet, or supplementation, then they are not becoming vitamin D deficient. And this was even shown in patients who are genetically mutated to be extremely sensitive to the sun. Like these were some of the patients that they're called xeroderma pigmentosa patients. They have to almost live in a bubble because of their sensitivity to the ultraviolet radiation. Even those individuals are not vitamin D deficient if they're repleted properly. So, but on the flip side, our skin's very efficient. We can make vitamin D pretty easily. And there was one study that showed if you're light-skinned, then you only need 9 minutes in the middle of the day without any sunscreen on to get all the vitamin D you need for the winter. And if you're darker skinned, then you need more like 25 minutes. So I think if you're very active and you're using sunscreen, because no one uses sunscreen exactly perfectly, you're getting enough vitamin D anyways. But if you were very, very careful and you wanted to make sure, you could just do a short exposure, per day and get enough. The other big controversy was that benzene was detected in sunscreen. This was done by a local watch group with Valashore, and one of my colleagues did looked at data from a large survey study of nutrients and health in a large population. And when they looked at that of self-reported sunscreen users, they actually had lower benzene levels than individuals who never use sunscreen. Benzene is a known carcinogen, and obviously you don't want to get exposed to it, but and we actually don't recommend spray sunscreens. Majority of the benzene was found in spray sunscreen anyway. So it was pretty easy for us to say just to avoid the spray sunscreens, but it certainly is not reason to avoid using sunscreen. And I think that's what some people took home. So in 2019, in light of those first two studies I showed you about sunscreen ingredients getting into the bloodstream, the FDA did propose changes. I think that's partially got interrupted because of the pandemic. So they said that zinc and titanium are safe and effective. They eliminated 2 ingredients completely, and they said more data needs to be taken on these 12 ingredients that were tested. They said that the ingredients that are in the sunscreen should be listed right in front, and that they should really emphasize the SPF number, the fact that they're broad spectrum, and whether or not they're water resistant. And they raised the maximum SPF to 60. And they require that any sunscreen SPF 15 or higher has to be broad spectrum. And if they're less than SPF 15, they actually have to have a sign saying they're skin cancer, skin aging alert. And there was also a study showing that the combination sunscreen bug sprays aren't effective. So I'm going to close up with a few other alternatives to sunscreen. This is obviously a hot area of research, and unfortunately there's not always good data for supplementation. So this is one that's been around a long time. Actually, Thomas Fitzpatrick came up with the skin phototype, discovered this ingredient from fern plants. So this is a plant that gives a natural protection against sunburn. So it's not meant to be used in replacement to sunscreen, but it's a good adjunct. And I have had a few patients who couldn't find a single sunscreen that didn't make them break out, that relied on this and using protective clothing. Then there's been a lot of news about nicotinamide, which is a vitamin B3 derivative, and its ability to protect against skin cancer. So this was in a New England Journal paper, randomized control study on the use of 500 milligrams of nicotinamide twice a day, and decreasing the risk of actinic keratoses, which is a precancerous lesion not related to melanoma, and non-melanoma skin cancer. So these are the 2 other most common skin cancers we see: basal cell carcinoma and squamous cell carcinoma. And it probably works by reducing UV-induced immunosuppression. There's been a lot of speculation that this may also help protect against melanoma, but that hasn't been demonstrated yet. I will say that one reason I am not giving this out to every patient is my cardiology colleagues are concerned that the nicotinamide is converted to niacin in the body. And in their even larger studies, so the skin cancer study was about 1,700 individuals, and the cardiology studies are 17,000 individuals. So in those large studies, niacin increases all-cause mortality. And then one last point that I wanted to make, which brings us back to some of the data that Dr. Fisher was showing, was this idea that the melanin itself is causing some of the DNA damage, that melanin releases reactive oxygen species, and pheomelanin does it more than eumelanin, the brown pigment. Was also this idea that of dark damage. So, you might be in the sun and at the beach, and then you retreat to the movie theater, and then you think, "Whew, I'm safe. I'm out of the sun." But little do you know that in the meantime, the reactive oxygen species that were released by the sun exposure is still continuing to ricochet off your DNA, causing damage. And this continues for at least 2 hours after exposure. So here again, we have that wild type mouse that has normal pigment. So they're experiencing DNA damage, 2 hours after exposure. And if you're a redhead with that mutant MC1R, you're experiencing even more DNA damage. So the only thing that quenches this continual damage is the presence of antioxidants. So the trouble is we don't have a lot of data on how do we replenish antioxidants at the level of the skin, what really works, and what people have been using are topical antioxidants, of which the most common form is topical vitamin C. And again, the data for skin cancer prevention is not there. There are some studies that suggest it improves photoaging. And the challenge is that delivery of vitamin C is challenging. Vitamin C is inherently an unstable product. And so I'm putting it out there that, I do have some patients use this. I don't even have a particular brand that I recommend. The data is not there, but it certainly isn't harmful to do either. Okay, so in summary, you want to look for broad spectrum. You have to have at least an SPF 30. And if you're going to be out longer, go for higher. Reapply every 2 hours or after toweling. It's not just about the sunscreen. In fact, early studies that showed that sunscreen users had more skin cancer was probably because the way people use sunscreen was they put it on one layer and then they went out for 8 hours and lay directly in the sun. So how you use your sunscreen is really important, and you have to combine protective clothing, shade avoidance. I always say that I've trained my patients well if when they're walking down the street, they move to the shady side, then I know they really got my message that they have to limit how much sun they get. If safety is first, then start with the physical blockers. There's just less controversy about them. I will say though that the way people use sunscreens, my own bias is that chemical sunscreens are used more correctly because most individuals don't want to have a white sheen. And then again, you can get your vitamin D if you want. And then the sunscreen use has to be tailored to the individual. You all start off with different skin colors that offer different inherent protection, and you have different lifestyles. So that all has to be taken into account in how you protect against the sun. And that's it. And these are our kids showing good sun protection behavior on the beach. Fortunately, we don't usually go to the beach. We're not beach people, but my husband grew up in San Diego, so when we visit them, we do take them. And then I had colleagues share their slides with me. Thank you.
Thank you so much, Jennifer. That was very helpful, I'm sure. And my thanks really to Mass General and the Brigham, not only for your participation tonight, but also because you're such good partners. For those of you who don't know, Mass General, Brigham are our sponsors in the city of Boston to provide sunscreen dispensers. This is a model project. Boston is the model city for doing this. And So we're very grateful to them for their continued support. Before we take some questions, the other piece that I will just say is that one of the areas that IMPACT Melanoma is starting to work on, and Lori's put something in the in the chat called Cat Shade, is that we're really looking at a little bit outside of the traditional box of how do we individually take care of ourselves in the sun. We're interested in sort of the intersection between UV, heat, and climate change. And one of the things that we're looking at is parts of cities where we know that there are more heat islands, or that because there is no shade, no trees, no shade structures, that we have parts of cities, and that includes Boston, that areas of the cities have are multiple degrees higher than other parts. And so what we're beginning to look at is what can we do about that? How can we provide shade? And so we are embarked on a journey to bring shade to the city and to take that model and bring shade to cities around the country. So stay tuned and look at our website. We have a new website page called Impact Shade. It talks about this initiative, and I'd love to have people engage with us with that. So with that, Lori, do we have some questions out there?
Yeah, there was 2 questions, and I think they were really well addressed by Dr. Fisher and Dr. Lin. But if we want to elaborate, how concerned should we be regarding sunscreen ingredients, which we are known to cause cancer, which I think you addressed that quite well. One just came through though. After treatment, how can I say I am cured when in reality the disease can reoccur at any time for the remaining of my life?
I can.
David, you want to take that one?
To that, sure. That's a big problem because when a disease has the capacity to remain dormant, or at least what functionally we would call dormant, meaning it's undetectable, but we have seen through experience that cancers, and by no means is melanoma unique in this, but that cancers can relapse many, many, many years later, sometimes 20 years later, longer even. There's several points to keep in mind. While it can happen, it usually does not. It unfortunately, for cases where it relapses, it typically happens within a shorter time frame. There is a psychological challenge in handling the duration years later when you've separated from the routine of coming back, receiving treatment, having scans, the very anxiety-provoking moments of what did the results show, going off of treatment at a certain point where hopefully things have gone well, and sort of breaking through a very challenging psychological moment. And then you just go to the next challenging psychological moment and the next challenging psychological moment. There's another name for this. This is life. We're all dying. We're all closer to the end. We're all going to relapse from something, or perhaps have something new occur. And I can tell you, as an oncologist who has dealt with this in children and as adults for many years, there is actually a way of accepting the good news that's there, even though it's not as good as we really wish it would be. So I would say, I think you're right. We cannot use the word cure, but there is a functional similarity that can be so close that you can still have joy, you can have comfort, you can, see the positive aspects of life, and do the best that you can with that. And I think that's the best we can do, but it's pretty good. And I would encourage you to see that light where it is.
I agree. I think we tell our patients that they are lifelong patients and that they will always be screened and looked for to make sure they don't make new melanoma. I do think that we're lucky in melanoma that 90% of the melanomas that are diagnosed are in stage 1. So, and stage 1 is the earliest stage where 96% of the time the melanoma won't come back. We just happen to catch it early enough that we surgically removed all the cells. So I agree with David that most of the time the news is good, and when you're in the unfortunate situation where it's not so clear, we do try to get back our patients back to living their normal lives, even though they sometimes feel like they have a specter hanging over them.
I would actually add one other tiny point, which is, and this is a way in which melanoma is different from most other cancers, which is in what hopefully will not ever occur, but in the unlikely case where it does recur, there's hope. Melanoma can again go into remission, and it may go into remission for such a long time that you know, old age will set in before the end point where it might even have relapsed again. So I would say that I think that's a really valuable piece to keep in mind, because there are other diseases where relapse has a much lower likelihood of long-term benefit.
Thank you so much. That's really helpful. And I think the thing that I remember from all of my years working with melanoma patients is that when I started many years ago, we had no treatments really. If somebody came to us and they were a stage 3 melanoma patient, we were just like, you know, let's make them happy for the time that they have, because we didn't have any. We had choices that had efficacy rates of 10 or 12%, and that was about it. And you look today at what an amazing place we're at. And it's because of folks like you that have made this possible. So we're very thankful for the work that you do. I would like to say one last thing, and that is IMPACT Melanoma has support groups for melanoma patients. We're just starting a newly formed national melanoma support group that meets virtually on the first Monday of the month at noontime, Eastern Standard Time. For more information, just go to our website under support and under the Get Support tab, and we'd love to have you join us. So Lori put also something in the chat as we finish this Zoom. If you have time on your hands tonight, we have an event called Martinis for Melanoma. It's a fundraising event. It's going on at 7 o'clock in Rhode Island, and it's virtual. So if you'd like to join us, the line is in the chat, and please be our guest tonight and for an hour or so, and you'll hear some wonderful speaking, and it'll be a fun hour or so. So I want to thank you all for joining us tonight, and come back to IMPACT Melanoma for any questions that you have. We're here for you. Kelly Braga is our social worker. She's fabulous and is around to answer your questions, provide support, or hook you up with a buddy to help you get through any of the difficult times. So with that, we'll say thank you very much and sign out for tonight. Thank you all for joining us. Good night.